Therefore, this is convergent. So just go through the previous video that a live stream is interrupted. Okay. So now I move on to 18th problem. So 18th problem is discuss the convergence of the series. So 18th problem. So 18th problem is summation square root of n plus 1 minus square root of n minus 1 divided by n. These are very easy problems, so you don't need to rationalize because already it is in rationalized form. So what you have to do is you just find Vn from this series and straight away find limit n tends to infinity Un by Vn. Okay. Now let us take Un to be equal to square root of n plus 1 minus square root of n minus 1 divided by n. Now you just take n common here. Now if we take n common here, so this will be square root of n into 1 plus 1 by n minus, again we take n common here, so it will be 1 minus 1 by n divided by n. Right? Now if you bring n to, I can take root n outside. If we take root n outside, here we will have 1 plus 1 by n minus square root of 1 minus 1 by n divided by n. Now we just bring this root n to denominator. So the numerator we will have square root of 1 plus 1 by n minus square root of 1 minus 1 by n divided by n power 1 minus 1 by 2. Because this I am just bringing n power 1 by 2 to the denominator, we will have n power 1 minus 1 by 2, which is nothing but n power 1 by 2. Now you take Vn. Take Vn to be equal to 1 by n power 1 by 2. Now what about limit n tends to infinity Un by Vn? So it is limit n tends to infinity. So our Un is square root of 1 plus 1 by n minus square root of 1 minus 1 by n into 1 by n power 1 by 2 divided by Vn is n power 1 by 2. This n power 1 by 2, n power 1 by 2 will get cancelled. So as n tends to infinity, this term tends to 0 and this term tends to 0. Right? This term tends to 0 and this term tends to 0 again. Square root of n plus 1 by n minus square root of n, so it will be 1 minus I think I made some mistake anyway. N plus 1 minus n minus 1 divided by n. So this will be root n plus 1 minus root n minus 1 divided by n. So we take n common, we will have 1 plus 1 by n. We take n common, we will have 1 minus 1 by n. And here n, so this will be n power 1 by 2, 1 minus 1 by 2, which is again 1 by 2. Now just take n Vn to be equal to n power 1 by 2. Now limit n tends to infinity Un by Vn. Now as n tends to infinity, this tends to 1, this tends to 1. Here we are getting 0, right? We are getting 0. Okay, just change this to plus. Right, so this will be, this tends to 2, this tends to 2, which is fine and non-zero. Right, so since summation Bn is divergent, summation Un is also divergent. Why? Because summation number 1 by 2 is divergent, is also divergent. So since the comparison test, both the series behave alike, so therefore it is divergent. So so I move on to 19th problem. So 19th problem is summation sine 1 by n. It is a very easy problem. So if you understand the first 19 problem, you can do any problem in your own. So we'll move on to the 19th problem. Summation sine 1 by n. Right? Summation sine 1 by n. We need to check whether the series is convergent or divergent. Now you just expand this. So you just make use of the formula that sin x is, so expansion of sin x is x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on. So x minus x cube by 3 factorial plus x power 5 by 5 factorial. Now we just expand sine. In place of x we will have 1 by n. So let us take un to be equal to sine 1 by n. So we just expand this. So if we expand this, we will have 1 by n minus 1 by n cube into 1 by 3 factorial plus 1 by n power 5 into 1 by 5 factorial and so on, minus and so on, right? So I have just replaced x by 1 by n, so there will be 1 by n, this will be 1 by n whole cube and that will be 1 by n whole power 5, right? Now we just take 1 by n common. Now if we take 1 by n common, this will be 1 and this will be 1 by n square 1 by 3 factorial plus 1 by n power 4 into 1 by 5 factorial and so on. Now you take Bn to be equal to 1 by n, right? Now what about limit n tends to infinity un by Bn? So this will be limit n tends to infinity. So our un is 1 by n into 1 minus 1 by n square 1 by 3 factorial plus 1 by n power 4 1 by 5 factorial and so on divided by Bn. So Bn is 1 by n. If I bring that to a numerator, we will have n and this n will get cancelled. Now as n tends to infinity, this term tends to 0, this term tends to 0 and all the terms tends to 0 except 1. So we will have only 1 which is finite and non-zero, right? So since it is finite and non-zero, use summation Bn is convergent, Un is also convergent. By comparison test, both the series behave alike. So therefore, since summation Bn, which is summation 1 by n, is divergent, right? Is divergent. So we just make that summation 1 by n power p is convergent but only if p is strictly greater than 1. Here p is equal to 1, so therefore the series is divergent. So since Vn is divergent, this implies summation Un is also divergent. So therefore the summation sine 1 by n is divergent. So you just have to make use of the formula that sin x is x minus x cube by 3 factorial plus x power 5 by 5 factorial. Now we will move on to 20th problem. So based on a comparison test, we are in 20th problem now. So 20th problem, summation sine 1 by n square. In the previous problem we have sine 1 by n, here you will have summation sine 1 by n square. Now let's take un to be equal to sine 1 by n square. Now you just expand this here, so it will be in place of x you just substitute 1 by n square. This will be 1 by n square minus 1 by n power 6 into 3 factorial plus 1 by n power 10 into 1 by 5 factorial and so on. To just replace x to be equal to 1 by n square. So 1 by n square cube is 1 by n power 6, 1 by n square whole power 5 is 1 by n power 10. Now you just take 1 by n square common. If you take 1 by n square common, this will be 1, and here we will have 1 by n power 4, 1 by 3 factorial, and here we will have 1 by n power 8, 1 by 5 factorial, and so on. Right? Now you take Vn to be equal to 1 by n square. The previous problem you have taken 1 by n, but here I am going to take Vn to be 1 by n square. The previous problem we don't have n square term, so that's why we didn't take n 1 by n square. Now what about limit n tends to infinity Un by Vn? Limit n tends to infinity. Now you can clearly see Un is 1 by n square into 1 minus 1 by n power 4 into 1 by 3 factorial plus 1 by n power 8, 1 by and so on, divided by Vn. So if I bring Vn to numerator, we will have n square. This n square and this n square will get cancelled. Because n tends to infinity, this term tends to 0, this term tends to 0. So we will have only one, which is finite and non-zero. So therefore, both Un and Vn behave alike. So since summation Vn, so what is summation Vn? It is summation 1 by n square. This is convergent. Why? Because summation 1 by n square is convergent, because p is equal to 2 here, which is either greater than 1. So therefore, summation Un is also convergent. So therefore, the series is convergent. So now we move on to the next problem, which is 1 by n sin 1 by n. 21st problem. Sin x is x minus x cube by 3 factorial plus x power 5 by 5 factorial. So 21st problem is 1 by n sin 1 by n, 1 by n sin 1 by n. Now just take Un to be equal to 1 by n sin 1 by n. Now just expand sin 1 by n. So in place of x, we just substitute 1 by n. So it will be 1 by n minus 1 by n cube into 1 by 3 factorial plus 1 by n power 5 into 1 by 5 factorial and so on. Now again you just take 1 by n common here. Now if you take 1 by n common, already here we have 1 by n, that means 1 by n square. So it will be 1 minus 1 by n square, 1 by 3 factorial plus 1 by n power 4, 1 by 5 factorial and so on. Right, so I am taking 1 by n outside. So this will be 1. Here 1, the power will get reduced by 1. So n square, n power 4 and so on. And already we have 1 by n outside, this will be 1 by n square. Now you take Vn to be 1 by n square. Now what about limit n tends to infinity Un by Vn? So limit n tends to infinity Un by Vn will be, so this entire term divided by 1 by n square, this term will get cancelled, this term tends to 0. So we will have only one, which is finite and non-zero. So both Un and Vn behave alike. So since Vn is convergent, why? Because summation 1 by n square is convergent. This implies summation Un is also convergent. So therefore the given series is convergent. Sin 1 by n is divergent. Sin 1 by n square is convergent. Sin 1 by n sin 1 by n is again convergent. So we will move on to 22nd problem. So 22nd problem is 1 by root n summation 1 by root n sin 1 by n, 1 by root n sin 1 by n. Now just take Un to be equal to 1 by root n sin 1 by n. Now just expand sin 1 by n. So it is nothing but 1 by n minus 1 by n cube into 3 factorial by 1 by n power 5 into 1 by 5 factorial and so on. Now again you take 1 by n outside. So if we take 1 by n outside, this will be 1 minus 1 by n square 1 by 3 factorial plus 1 by n power 4 into 1 by 5 factorial and so on. Now you just take, now if you multiply this, so root n into n is n power 1 by 2 into n power 1, which is n power 3 by 2. Now you just take bn to be equal to 1 by n power 3 by 2, right? Now you find limit n tends to infinity un by bn, and this will be equal to 1, because you can see this n power, this will get cancelled. So as n tends to infinity, this term tends to 0, this term tends to 0, so we have only 1, so which is finite and non-zero, which is finite and non-zero. Therefore both un and bn behave alike. So since summation bn is convergent, why? Because summation 1 by n power 3 by 2 is convergent, because here you can see p is 3 by 2, which is greater than 1. Therefore this is convergent. This implies summation un is also convergent. Therefore this series is convergent. So sin 1 by n is divergent, sin 1 by n square is convergent, sin 1 by n sin 1 by n is convergent, 1 by root n sin 1 by n is convergent again. Now next series is cos 1 by n, summation cos 1 by n. So 23, summation cos 1 by n, right? So we need to check whether this series is convergent or divergent. Now what is un here? Un is cos 1 by n. Now you can expand cos 1 by n in the cos x expansion, or you can simply see that what limit n so un has to be equal to 0, then only we can make use of any result, right? So limit n tends to this will be cos 1 by infinity, this will be cos 0, which is 1. So you can say this is not equal to 0. So a series is convergent. The necessary and subject condition for a series to be convergent is that limit n tends to infinity has to be equal to 0. Then only we can check whether this is convergent or divergent. But if it is not 0, we can simply straight away say that the series is divergent. If it is equal to 0 only, it may or may not be convergent. Then only we can make use of some other test to check whether it is convergent or divergent. But if the limit n tends to infinity is not equal to 0, then straight away you can simply say that it is divergent. So you just see the previous two videos, you will get very good idea. So if you straight away watch this video, it will be more tricky for you. So just do problem 1 by n. This is 23rd problem. So you just refer problem 1 to 22, so that it will be very clear for you. Now next problem is tan inverse 1 by n, 24. Summation tan inverse 1 by n, tan inverse 1 by n. So again you just make use of tan inverse x formula. So what is tan inverse x? Tan inverse x is x minus x cube by 3 plus x power 5 x cube by 3 plus x power 5 by 5 and so on, right? So in sin x we will have factorial, in tan x we don't, in sin x we will have factorial, 3 factorial, 5 factorial, but for tan inverse x we don't have factorials in the denominator, which is called as a Grigori series. This is a special name called Grigori series. Right? So tan inverse x, again it's a very fundamental formula that you come across in school. So just make use of this formula. So we have un is tan inverse 1 by n. So instead of x we just substitute 1 by n. So we'll have 1 by n minus 1 by n cube into 1 by 3 plus 1 by n power 5 into 1 by 5 and so on. Now we just take 1 by n common. So it will be 1 by n square into 1 by 3 plus 1 by n power 4 into 1 by 5 and so on. Now you just take bn. Vn to be 1 by n. Now what about limit n tends to infinity un by vn? So un by vn. So if we divide this un by vn, this 1 by this 1 will cancel. As n tends to infinity, this term tends to 0, this term tends to 0. So we will have only one, which is finite and non-zero. So both the series behave alike. So since both the series behave alike, so since summation Vn is divergent. Why? Because summation 1 by n is divergent. Vn is 1 by n is divergent. This will be convergent if and only if the power of n is strictly greater than 1. So therefore the series is divergent. So therefore summation Vn is also divergent. Tan inverse 1 by n is divergent. Now the next problem is cot inverse n square. Cot inverse n square. So this is the last problem in comparison test. Now the next we will move on to ratio test, D'Alembert ratio test. Now 25th problem is summation cot inverse n square. So we have un is cot inverse n square. So cot inverse x is same as, so just make use of this result. Cot inverse x is same as tan inverse 1 by x, right? This I can write this as tan inverse 1 by n square. Tan inverse 1 by n square. Now again you make use of the formula, summation tan inverse x formula. So if you expand this, you will have 1 by n square minus 1 by n power 6 into 1 by 3 plus 1 by n power 10 into 1 by 5 and so on. Now we just take 1 by n square common, so we will have 1 by n power 4 into 3 plus 1 by n power 8 into 1 by 5 and so on. Now you just take Vn to be equal to 1 by n square. Now what about limit n tends to un by vn, which is equal to 1, so which is finite and non-zero. So since summation Vn is convergent, so since summation Vn, it is summation 1 by n square, this is convergent. So therefore summation Un is also convergent. Therefore the series is convergent, right? So what we did so far is we have solved 25 problems based on comparison test, right? So what we are going to do now is, okay, there are some problems. Okay, so there are, okay, we finished almost all problems. So we need to test the convergence of a series summation x power n minus 1 divided by 1 plus x power n, and this x is greater than 0, right? So or test the convergence of 1 by 1 plus x plus x by 1 plus x square plus x square by 1 plus x cube. I'm just substituting n to be equal to 1, 2, 3, etc. That's it. So test the convergence is a very important problem. That's the convergence of the series summation x power n minus 1 divided by 1 plus x power n, or test the convergence from 1 by 1 plus. Okay. Actually the first time we are seeing x, right? First time we are seeing x. So all the previous problem we are only dealing with numbers. So here we will have, here we have x. So x power n minus 1 divided by 1 plus x power n. So we're going to split this into 3 cases, right? So here we have un. So we have un is x power n minus 1 divided by 1 plus x power n, right? So we divide this into 3 cases, right? So case 1. So case 1, case 2, and then case C. So in case 1, what I'm going to do is I'm going to when 0 is less than x is less than 1. So you always do this term. So whenever you have x and x is greater than 0, so what you do is you just see whether how the beginning of the series when x lies between 0 and 1, and what happens when x is equal to 1, and what happens if x is greater than 1. Right? So we always split this into 3 parts. So since x is greater than 0, so it's divided into 0 to 1 and 1 and greater than 1. So you just split it into 3 cases. So when 0 is less than x is less than 1, what happens to the series? Okay. Okay. Now what is un? So un is x power n minus 1 divided by 1 plus x power n, right? So this I can write this as x power n into x power minus 1 divided by 1 plus x power n. Now just take x power n outside, so we will have 1 plus 1 by x power n, so this two will get cancelled. So we have okay, what we will do is we need to check the convergence, right? So what we will do is, so we will not cancel. Now just take x power n outside. So it will be 1 plus 1 by x power n. Okay, no problem. What we will do is, so we have un is equal to x power n minus 1 by 1 plus x power n. Now you just take bn to be equal to x power n minus 1, right? You just take bn to be equal to x power n minus 1. Now what about limit n tends to infinity un by vn? So this is nothing but limit n tends to infinity. Our un is x power n minus 1 divided by 1 plus x power n, and vn is x power n minus 1. So it will be x power n minus 1. This two term will get cancelled. So this will be limit n tends to infinity 1 by 1 plus x power n, and this tends to 1. Why? I'm claiming that x power n tends to 0 as n tends to infinity. Why? Because we can see this is a geometric series, and the geometric series, this will be convergent if x is in between 0 to 1, right? That is mod x has to be less than 1, so therefore this term tends to 0. A very important thing, x power n tends to 0, this is tending to 0 because our x is in between 0 to 1, right? That is geometric series valid whenever mod x is strictly less than 1, so this term tends to 0. So therefore since it is 1, so finite and non-zero, so therefore both u and vn converge or diverge together. Okay, so therefore both converge or diverge together. This implies summation vn is convergent. Why? Because summation vn is also convergent. Why? What is summation vn? Summation vn is summation x power n minus 1, which is a geometric series again, and this is valid because x lies between 0 to 1. So therefore this is a geometric series, so therefore this is convergent, so therefore the un is also convergent. Now what happens when x is equal to 1? When x is equal to 1, our un is, so we just take 1 power n minus 1 divided by 1 plus 1 power n, which is 1 by n. So therefore the limit n tends to infinity un is 1 by 2, which does not tending to 0. We can say that it is divergent. Right? So what happens when x is greater than 1? So when x is in between 0 to 1, we can apply geometric series, so therefore this will be convergent. And what happens when x is greater than 1? So when x is greater than 1, can I say 1 by x is less than 1? Okay. So when x is greater than 1, can I say 1 by x is less than 1? Okay, so 1 by x is less than 1. So we have un to be x power n minus 1 divided by 1 plus x power n, and so here what I am doing is I am just taking 1 x power minus 1 outside, so it will be 1 by x power n by 1 plus x power n. So here I am just writing x power n minus 1 as x power n into x power minus 1, and I'm bringing x power minus 1 as 1 by x, right? Yes. Now what about limit n tends to infinity un? As n tends to infinity, so since since we have 1 by x is less than 1, okay, so can I say 1 by x power n tends to 0? So since 1 by x is less than 1, can I say 1 by x power n tends to 0? Right? So you can see here x is less than 1, so therefore x power n tends to 0. Here 1 by x is less than 1, so therefore again by geometric series 1 by x power n tends to 0. Now here what I'm writing this? I'm writing this as 1 by x into, I'm writing x power n as, okay, what we will do is we will take x power n outside, so we will have 1 plus 1 by x power n, which is 2 term will get cancelled. But n tends to infinity, 1 by x power n tends to 0, so this will be 1 by x, which is again not equal to 0. So limit n tends to infinity even is equal to 1 by x. So depending upon the value of x, it has to be equal to 0, then only it may or may not be convergent. Since it is not equal to 0, so therefore it is divergent, right? Therefore the given series, so when x lies between 0 to 1, it will be convergent, and when x is equal to 1, it is divergent, and when x is greater than 1, it is also divergent. So similarly, can you do this problem? Discuss the convergence of 1 by x power n plus x power minus n. So whenever you have some x, you just split this into 3 parts. So we can also do this by ratio test also. So what we will do is, after completing all the tests, we will do this similar problem in ratio test also. So discuss the convergence of 27th problem, so which is 1 by x so 1 by x power n plus 1 by x power minus 1. So what is un here? So just take u1 to be equal to 1 by x power n plus x power minus n. So again by case 1, when 0 is less than x is less than 1. When x is equal to 0, and case 3, when x is greater than 1. So when 0 is less than x less than 1, x power n tends to 0 as n tends to infinity, because you can say our x lies between 0 and 1. So what about you just take bn to be equal to x power n, right? Now what about limit n tends to infinity un by bn? So it is limit n tends to infinity, so un is 1 by x power n plus x power minus n divided by bn. So if I bring 1 by x power n to numerator, it will be x power n. Now this will be, now if I take x power n common, you will have 1 plus 1, right? Okay, so again this tends to 1 as n tends to infinity, because this tends to, this will get cancelled. So as n tends to infinity, this term tends to 1 by 2 x power n. Okay, or else you can also do like, you can write x power minus n as 1 by x power n, 1 by x power n. So this will be x power n by x power 2n plus 1, limit n tends to infinity. So again x power 2n plus 1. Now just take x power n common, this term tends to 1 again, which is equal to 1, so which is finite and non-zero, right? You just take x power n here, so here we will have Okay, right. Yes. You make use of the result that x power n tends to 0 as n tends to infinity. So therefore, since this is finite and non-zero, both bn and un behave alike. So bn is summation 1 by x power n. It is convergent. So geometric series, summation x power n is geometric series and x lies between 0 to 1. It is convergent. So therefore, summation un is also okay. So when x is equal to 0, what happened when x is equal to 0? So our un is 1 by x power n plus 1 by x power minus n. So this is nothing but x power 2n plus 1, right? So as n tends to infinity, you can see. So what happened when x is equal to 0, right? Sorry. When x is equal to 0, this will be 0 power 2n plus 1, which is equal to 0, which is not tending to 0. Which is not tending to 0. So we can straight away say that this is not divergent. It is divergent. And also when x is equal to 1, 0 is the conversion. When x is equal to 1, to 1 by 2, again it is not tending to 0, right? So therefore again this is also divergent. So when x is greater than 1, so again 1 by x is less than 1. So this implies 1 by x power n tends to 0 as n tends to infinity. 1 by x power n tends to 0 as n tends to infinity. Now again you just find the same problem on. Let's take bn to be equal to 1 by x power n. Now you just find limit n tends the same as previous problem, right? So you will get this term to be equal to 1, which is finite and non-zero. So both un and bn behave alike. So bn is summation bn is divergent. So since summation bn is convergent, so therefore because this is nothing but summation 1 by x power n, and this is convergent because 1 by x power n is less than 1, right? Because 1 by x power n tends to 0 and 1 by x is less than 1. So therefore summation un is also convergent. So when x is equal to 1, the series will be divergent, and when other than the value of x is equal to 1, then this series will be convergent. Okay? So the next video we will start ratio test. So based on the ratio test we will solve around 20 problems. Okay? So that's it. Thank you.